Here is the last question on our series of graph linear relations. So we are trying to practice for the test so that we can do well on this topic. And I hope in these 10 questions you've learned a lot. Well, this question number 10 is unique and I'll explain you how. Let's first read the question. Question number 10 is, at a concert, adult tickets cost $5 and students' tickets cost $4. A total of $40 in tickets money was collected in the first 10 minutes. Write an equation and display the information on a graph to show the possible number of tickets of each kind that could be sold. Now, the interesting part here is that normally in a graph you will plot independent variable along x-axis and the dependent variable along the y-axis. Now in this question we have tickets, and one type of tickets is for the adults which cost $5 and the other type is for the students costing $4. Now out of these, which one do you think is independent variable? A very difficult question to ask. And answer 2, right? In fact, either one is okay and you can't really say for sure that one is independent and the other is dependent. So that is how this question is very special. Now you could get a lot of linear relations where independent and dependent variables don't have a clear line of demarcation like this one and the next series which we are getting into, right? Now these situations can be represented in the form of an equation with this kind of an equation, ax plus by equals to c. So first I will write down an equation in this form and then we'll plot a graph. Let's read the question. At a concert, adult tickets cost $5 and students' tickets cost $4. Total of $40 in tickets money was collected in the first 10 minutes. So we know the amount collected. So we'll define our variables as we did in all the videos. Let the adult tickets sold be A. So we'll define variables which have some meaning. So we'll say let A, so you have to write the let statement, which I'm not writing here. Let A be number of adult tickets. And let S be the number of students' tickets, correct? Sold. Now, if you sell a number of adult tickets, how much revenue do you get? Each is $5, right? So you get 5 times a number of tickets sold. If you sell S number of tickets for students, what revenue do you get? 4 times S. Since every ticket costs $4, so I can write this as 4 times S. Now it's written a total of $40 in the tickets money was collected in the first 10 minutes. So the total amount should be $40. Correct? So this is dollar, this is dollar, this is dollar, and that forms the equation. That is how we get our equation. The equation 5a plus 4s equals to 40 represents this situation. Now let's go ahead. Write an equation and display the information on a graph to show the possible number of tickets of each kind that could be sold. So now to represent this equation on the graph, what we can do is that we can find a set of points. So make a table of values, and good points to get are the points where A and S could be like 0 or something like that. So let's write down some values and calculate. We need a total of 40, correct? So if I choose A, we'll write some values for A and some for S. If I choose A to be 0, in that case, what should be the value of S? That is how we need to calculate. So if this is 0, then S will be 40 divided by 4, and that gives me 10, right? Now if I choose S as 0, then if I choose s as 0, in that case a will be 40 divided by 5, which is 8. So these are good points to start with. So what we can do is we can plot these points, and now before that we have to decide on which axis should we take a and on which axis should we take s. Now as you see, both are kind of dependent variables, right? So it doesn't really matter. So what we will do for the time being is we can take a, the number of adult tickets on x-axis, and s, the number of student tickets on the y-axis, right? This is a very specific case where, actually speaking, none of the variable is independent in true sense, right? So they are dependent on one another. So we say, well, if a is 0, then s is 10, and if s is 0, then a is 8. So that will help us to decide about the scale. We have 1, 2, 3, 4, 5, 6, 7, 8, good number of divisions here. How about this place? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We can still work with it, correct? So the first point which we are going to get is a0 as 10. So that is this point for us. And then a is 8 when s is 0. So that gives us a point 1, 2, 3, 4, 5, 6, 7, 8, right? So that is how we get 2 points. So we can get some other points in between these values, correct? So let's have some value. Let's say a is, for example, 2. If I put 2 for a, 5 times 2 is 10, correct? And 40 minus 10 is 30, and 30 divided by 4 is not a good number. So that is not a good value to take. So we can try some other number. So let's try a value 4, right? So let's try a value 4. 2 really didn't work for us. 4 times 5 is 20. 40 minus 20 is 20. And 20 divided by 4 is 5. That works. So for a as 4, s is 5. 1, 2, 3, 4. We go up 5 units. 1, 2, 3, 4, 5. Correct? So we get another point. You will find that these points will lie on this particular line, correct? That is how these points are going to lie. So they are, in a way, linear. Do you get the point? So that is how we can do it. Now, another important thing to understand here is that we cannot really connect these points. Why? Because we cannot buy 1.5 ticket. Do you see that? So that is kind of an issue here. So it is a linear curve. We'll call it a scatter plot. And you should not connect these points. So they are separate. So do this exercise of figuring out what are the possible values of a and s which will give you good numbers here to plot. Well, all of them will lie on these points, correct? Joining a and s, the ones which we have shown here. So that is how you are going to draw this graph, correct? And that helps you to visualize that a and s both are related with one another. If the number of tickets for a increases, number of tickets for s will decrease, right? So as an additional problem, what you can do is that you can find 2 more points on this table and plot them here, correct? So that will be an exercise for this. I hope at the end of this series you understand how to graph linear relations. You also understand that in linear relations, most of the time independent variable comes in your x-axis direction and the dependent variable is taken along the y-axis. But there could be situations where you can't really decide which one is independent and which one is dependent. Most of the cases will involve equation like ax plus by equals to c. We'll explore these more in the coming videos. Have fun and enjoy. Thanks and all the best.